Hello everyone, welcome to Applied Chemistry Tutorials. So today we are going to discuss about factorization by Sridharacharya formula and its derivation. So in our last video we have discussed about polynomials, is classification, and factorization by splitting the middle term. So we can find the link here. And today we are going to talk about the limitation of factorization by splitting the middle term, and following on we are going to discuss about the Sridharacharya formula. So before going into details about the limitation, just have a quick recap. Say we need to factorize a given quadratic trinomial px equals to x square minus 5x plus 6 by splitting the middle term. Then we can have x square minus 5x plus 6 equals to x square plus minus 5 multiplied by x plus 6. Now we can split minus 5 into minus 3 and minus 2. So if we add minus 3 and minus 2, we can have minus 5. And if we multiply minus 3 with minus 2, we'll have 6, which equals to 1 multiplied by 6, or 6. So from this we can have x square minus 3x minus 2x plus 6. Now from the first two terms, if we take x as the common factor, we will have x multiplied by x minus 3. And from the third and fourth terms, if we take minus 2 as the common factor, we will have minus 2 multiplied by x minus 3. So from both of this term, we can see that we can take x minus 3 as the common factor. So that gives us x minus 3 multiplied by x minus 2. This is the results we are getting after factorization of x square minus 5x plus 6 by splitting the middle term. Now say we need to factorize another quadratic trinomial qx equals to x square minus 70x plus 1081 by splitting the middle term. So someone might wonder that how to split minus 70 so that it matches the criterion, which is AC equals to B1 B2, where ax square plus bx plus c is the general equation of a quadratic trinomial, and b split into B1 B2, that is b equals to B1 plus B2. So we have discussed this in details in our last video. So what should be the way out? For that we are going to talk about the Sridharacharya formula. Sridharacharya, an Indian mathematician, came up with a formula to find out the roots of quadratic equations. If a quadratic trinomial is equal to 0, such as ax square plus bx plus c equals to 0, where x is variable and a, b, c here are constants and coefficients of x square, x to the power 1 and x to the power 0 respectively, then we can have the roots of the quadratic equation as x equals to minus b plus minus root over of b square minus 4ac divided by 2a. So application of Sridharacharya formula. So let's apply this formula to factorize the given quadratic trinomial px equals to x square minus 5x plus 6. So the problem statement, x square minus 5x plus 6, and we can rewrite this as x square plus minus 5 multiplied by x plus 6. So before applying the Sridharacharya formula, let us have a quick recap. When the quadratic equation is ax square plus bx plus c equals to 0, the roots will be minus b plus minus root over of b square minus 4ac over 2a. Now in this problem we try to find out the similarities between these two equations. We can see that a equals to 1 here, b equals to minus 5 and c equals to 6. So applying Sridharacharya formula for px equals to 0, that means x square minus 5x plus 6 equals to 0. we can easily find out the roots using this formula. So here we are getting minus of minus 5 plus minus root over of minus 5 whole square minus 4 multiplied by 1 multiplied by 6 and divided by 2 multiplied by a. So after simplifying this, we are having 5 plus minus root over of 25 minus 24 divided by 2. Or for the simplification, we can have 5 plus minus 1 divided by 2. Now clearly we can see there are two roots, 5 plus 1 by 2 and 5 minus 1 by 2. So let us solve for this. So when x equals to 5 plus 1 by 2, we can have x equals to 3, and when x equals to 5 minus 1 by 2, we can have x equals to 2. So definitely the roots of the equation px equals to x square minus 5x plus 6 equals to 0 are 3 and 2. Therefore, when x equals to 3, we will have px equals to 0, which implies to when x minus 3 equals to 0, we can have px equals to 0. Similarly, when x equals to 2, we will have px equals to 0, and that means when x minus 2 equals to 0, we will have px equals to 0. So definitely we can see these are the two factors of the given trinomial. So we can say that px equals to x square minus 5x plus 6, which equals to x minus 3 multiplied by x minus 2. Now the results we obtained by applying the Sridharacharya formula matches exactly with the result we obtained from the factorizing by splitting the middle term. Now let's go back to the second problem. Factorize qx equals to x square minus 70x plus 1081. So rewriting the problem statement, x square minus 70x plus 1081 equals to x square plus minus 70x plus 1081. So we are writing this as ax square plus bx plus c format. So again, when the quadratic equation is ax square plus bx plus c equals to 0, we can find out the roots as x equals to minus b plus minus root over of b square minus 4ac over 2a. And now if we want to match, we can have a equals to 1, b equals to minus 70 and c equals to 1081. So now applying Sridharacharya formula for qx equals to 0, so we are having x equals to minus b, so minus of minus 70 plus minus b square, so minus 70 square minus 4ac, so 4 multiplied by 1 multiplied by 1081 and divided by 2a, so 2 multiplied by 1. So after simplification, we can have x equals to 70 plus minus root over of 576 divided by 2. On further simplification, we can have x equals to 70 plus minus 24 by 2. So definitely we can see there are two roots, x equals to 70 plus 24 by 2 and x equals to 70 minus 24 by 2. So let's find these values. So when x equals to 70 plus 24 by 2, we will have x equals to 47, and when x equals to 70 minus 24 by 2, we will have x equals to 23. So from this we can say that the factors for the given quadratic trinomial is x minus 47 multiplied by x minus 23. So now if it is absolutely necessary to factorize a quadratic trinomial by splitting the middle term, such as qx equals to x square minus 70x plus 1081, as we have mentioned in our previous problem, and someone can't figure out how to split the middle term, then it may be useful to apply Sridharacharya formula to find out the roots for qx equals to 0. So we just found out the roots for qx equals to 0, so which are x equals to 47 and 23. So now we can factorize it by splitting the middle term using the roots. So this is kind of a back calculation method I am going to show. So we can have this from the problem statement. So we can rewrite it as x square plus minus 70 multiplied by x plus 1081, and from this we can simply rewrite this as x square plus minus 47 plus minus 23 whole multiplied by x and 1081. You can see that if we add minus 47 with minus 23, it will give us minus 70, and if we multiply minus 47 with minus 23, it will give us 1081, which equals to 1 multiplied by 1081. So now if we expand it, we can have x square minus 47x minus 23x plus 1081, and if we take x as the common factor from the first two terms, we will have x multiplied by x minus 47. Similarly, if we take minus 23 as the common factor from third and fourth terms, we can have minus 23 multiplied by x minus 47. So from both of these terms, we can take x minus 47 as the common factor. So we'll have x minus 47 multiplied by x minus 23. So this is the factorized form of the given quadratic trinomial x square minus 70x plus 1081. Please note that use this technique only if it is difficult to determine how to split the middle term, and at the same time it is required to show your work. So let's go through these algebraic identities before deriving the Sridharacharya formula. Identity 1, a plus b whole square equals to a square plus 2ab plus b square. Identity 2, a minus b whole square equals to a square minus 2ab plus b square. Now from identity 1 and identity 2, we can have identity 3, where a plus b whole square can be rewritten as a minus b whole square plus 4ab. And similarly, from identity 1 and identity 2, we can have identity 4, which is a minus b whole square equals to a plus b whole square minus 4ab. Now let us discuss about the derivation of Sridharacharya formula. Let's find out the roots for ax square plus bx plus c equals to 0, as we are discussing in our last few slides. So from the problem statement, we are having ax square plus bx plus c equals to 0. So we can rewrite it as ax square plus c equals to minus bx. So we are subtracting bx from both sides. Now next we can divide both sides with x. So we can have ax square plus c divided by x, which equals to minus b. Now from this, if we split this term, we can have ax square over x, which is ax, plus c over x equals to minus b. So we are calling it as equation 1. Now squaring both sides of equation 1, we can obtain ax plus c over x whole square equals to minus b whole square. So after applying identity 3, we can have ax minus c over x whole square plus 4 multiplied by ax multiplied by c over x equals to b square. So remember that in identity 3, we have shown that a plus b whole square equals to a minus b whole square plus 4ab, and we are applying the same here. So now from this we can have ax minus c over x whole square and equals to b square minus 4ac. So here x and x cancels out, so it remains only 4ac, and we are subtracting 4ac from both sides, so it remains as ax minus c over x whole square equals to b square minus 4ac. And from this, if we take square root on both sides, we can have ax minus c over x equals to plus minus root over of b square minus 4ac, and we are naming it as equation 2. Now adding equation 1 and equation 2, we can get from equation 1 ax plus c over x equals to minus b, and from equation 2 ax minus c over x equals to plus minus root over b square minus 4ac. So when we add them, so c over x cancel out from both these equations, and we can have 2ax equals to minus b plus minus root over of b square minus 4ac. So here we are just adding the term on the left hand side as well as on the right hand side. So from this we can have x equals to minus b plus minus root over of b square minus 4ac divided by 2a. So we are dividing both sides by 2a. So this is the given formula, which is famously known as Sridharacharya formula, and we are utilizing it for factorizing the quadratic trinomials. So please note that this is one of the methods to derive the Sridharacharya formula, and there may be many other ways to do that, but I just showed you the way I used to derive it when I was a freshman at my high school. Similarly, quadratic binomials can also be factorized, and their associated quadratic equation, and then find out the roots using the Sridharacharya method. And as an example, if x square minus 4x equals to 0, here we can definitely see c equals to 0. And another example, 4x square minus 1 equals to 0, here we can see that b should be equals to 0, and we can use the same formula to factorize both x square minus 4x and 4x square minus 1 respectively. But these are so simple that we don't need either this Sridharacharya formula to find out the factorized form, or we don't need to factorize it splitting the middle term. So that's all for today, and if you like this video, please give us a thumbs up and share this video, and also subscribe to our channel.